Good morning, everyone. Mechanics of materials, torsion. Let's review an interesting fact in torsion in circular shaft. So if we have a solid circular shaft like what you can see here, and a torsional torque like T applied at one end, we can use tau maximum shear stress is equal to torsional torque times the radius of the shaft over J, which is half of pi c to the 4. And if we have like a combined shaft and the same torsional torque applied at the free end, you can again use the same equation, but be careful, tau maximum this time applied on the smaller portion because the J is smaller in this section. Like if we call it section 1, section 2, we need to use J1 in order to get the maximum shear stress. But due to abrupt change in the cross section, this formula it's we cannot say that's wrong, but that's not very accurate. So that's like just in theory because due to this abrupt change in cross section, tau maximum at the transition is much higher than this formula, maybe something like a higher coefficient than 1, definitely. So, but in torsion in circular shaft, we use the same equation in theory for calculation of tau maximum. Even though we have like 10 different shaft size, we use the same equation. But in design or in engineering practice, we can take care of that problem. And that's like if the same torsional torque apply and we use fillet for the transition part, tau max is then equal to a, a stress reduction factor, which is definitely higher than 1. So if this is higher than 1, this is like definitely higher than that one also, maybe 2, maybe 2 point something. Tau maximum is K times Tc over J. And we call K like a stress concentration factor, which as soon as we use the fillet, we have like a kind of use of a more pragmatic approach for torsion in circular shaft with fillet. And then, for example, if you use for example, in this part, we use a fillet by radius of 9 over 16 inches. Then we increase the radius of fillet to 15 over 16. Then you can easily see that K is reduced as soon as we use a higher radius in terms of our fillets. So 9 over 6 inches for the fillet result in a stress concentration factor of 1.33, and as soon as we increase the radius of the fillet, the stress concentration factor reduces to 120. So the higher the radius of fillet, it just make the transition more smooth. Thank you. We'll discuss more related problem in next videos.